Welcome to all. I am Sumathi from PG Department of Mathematics, Sithalakshmi Ramaswamy College, Trichy. In this video, we are going to learn how to find the number of spanning trees of any graph with a large scale of vertices using Kirchhoff's theorem. Basic concepts in graph theory. A graph is a set of points called nodes or vertices which are interconnected by a set of lines called edges. Connected graph is a graph in which at least one path between every pair of vertices. Spanning subgraph is a subgraph in which all the vertices of G appear. Tree is a connected graph with no cycle. Here, G is a graph with 4 vertices and 5 edges. Here, H1 and H2 both are subgraph of G. And H1 is a spanning subgraph of G and H2 is a subgraph of G because H2 has 4 vertices as in G, but H2 has 3 vertices. Therefore, all the vertices of G appear in H1. Therefore, H1 is a spanning subgraph. Spanning tree. Spanning tree is a subgraph, that is a tree that includes all the vertices of the original graph. Here we take C4. C4 is a connected graph with 4 vertices and 4 edges. The given below are the 4 spanning trees of C4. Therefore, number of spanning trees of C4 equal to 4. Here, K4 is a complete graph with 4 vertices and 6 edges. These are the spanning trees of K4. Therefore, finding number of spanning trees of given graph is very difficult. Here, number of spanning trees of K4 is equal to 16. Therefore, using Kirchhoff's theorem, we can easily find the number of spanning trees of the given graph G. Kirchhoff's theorem, it states that the number of spanning trees in a graph is equal to cofactor of any element of the graph's Laplacian matrix. It is also known as Kirchhoff's matrix tree theorem. Kirchhoff's theorem. For this, first you have to construct the Laplacian matrix L of the graph G and delete any ith row and jth column of the given Laplacian matrix L. We obtain the submatrix L dash and compute the determinant of L dash. This determinant value of L dash is equal to number of spanning trees of G. Here we take cycle C4 with 4 vertices. For this, you have to first find degree matrix and adjacency matrix. Degree matrix is a diagonal matrix whose diagonal entries are degrees of the vertices of the given graph G. Here, each and every vertex of G having degree 2. Degree means that number of edges incident with the corresponding vertex. Therefore, each and every vertex of this graph G having degree 2. Therefore, degree matrix 2, 0, 0, 0, 0, 2, 0, 0, 0, 0, 2, 0, 0, 0, 0, 2. Here, the diagonal entries are 2. Next one, to find adjacency matrix of G. Adjacency matrix is a matrix whose rows and columns are number of vertices of G. That is, here G is having 4 vertices. Therefore, adjacency matrix with 4 rows and 4 columns. Number of vertices incidence with the corresponding vertex. That means that here vertex 1, 2 and 4 are the incident vertices. Therefore, 1 comma 2 and 1 comma 3 whose entry is 1. 1 to 1 there is no edge, therefore whose entry is equal to 0. In a similar way we get 0 1 1 0 0 1 0 0 1 1 0 0 1 0 1 1 0. It is the adjacency matrix of the given graph G. Next one, to find the Laplacian matrix of the given C4. Therefore, first find the degree matrix, next to find adjacency matrix, next using matrix subtraction we get L, that is 2 minus 1 minus 1 0 minus 1 2 0 minus 1 minus 1 0 2 minus 1 0 minus 1 minus 1 2. Next, to find the cofactor of any element. Let us take first entry 1 comma 1 equal to 2. Now to find the cofactor of this 2. Therefore, omission of the corresponding entry of 2, that is omission of the corresponding entry means that corresponding row and column of 2. We get the submatrix 2 0 minus 1 0 2 minus 1 minus 1 minus 1 2, whose determinant value is equal to 4. Therefore, number of spanning trees of this C4 equal to 4. We take any element instead of 2, we get the same value equal to 4. Applications of Kirchhoff's theorem. It is used to find the counting spanning trees, next in network reliability and in computer network analysis. Thank you.